Hi, everyone. About a minute on the iron law of power density, part 2. That's the title of my latest piece on Substack. And in this piece, I talk, of course, about the iron law of power density, which says the lower the power density, the higher the resource intensity. But the piece also focuses on energy return on energy invested, EROEI. And why do I talk about this? Because this is another critical metric in physics. And it just makes sense. When we put money in the bank, we want the biggest return on our investment as we can get. Or if we buy a stock, of course, we want as big a return on our investment as we can get. Same is true in the energy business. It takes energy to produce energy. Whether you're drilling for oil, whether you're making solar panels, whether you're refining uranium, you have to spend energy to get energy. So we want, the ideal then is energy sources that have a high energy return on energy invested. And that's why wind and solar, in my view, continue to be, and the physics show that they're not the way to go. Why? Because the energy return on energy invested is low. As I point out in the piece, you put 1 unit of energy into wind and solar, you get about 3.5 units out. That's roughly break even. In the oil and gas business, you put in one unit of energy, you get about 30 out. For nuclear, 1 unit in, you get about 100 out. So this energy return on energy invested is a pretty simple metric in physics, but it's critically important. It's critically important to understanding our energy and power systems, and it's kind of a twin in some ways to the iron law of power density. So I encourage you to check it out. You know where to find me on Substack, robertbryce.substack.com. Thanks a lot. See you.